Hi again, everybody. Well, let's crack on. Let's crack on with our Python. Okay, and what we're going to do today is we're now going to make a colourful light, and we're going to control an RGB LED using pulse width modulation. But this time we're going to be using 3 potentiometers. Okay, so let's go to the wiring. Let me just come over to my, bear with me. Let's come over to the overhead view. So I just want to make sure you can see this. So now you might be able to see this better with this new camera. Let's hope it focuses. You can now see all the markings on the RGB LED. So what we're going to do, let's start. So as you can see on this right hand side is the plus. Yeah, oh, you can see that. Yeah, on the plus. And we're going to our connection here. You can probably see all the names now. These new cameras are brilliant, aren't they? So there we go. So this goes to the 5 volts. Right. That goes to the 5 volts. The next colour we want is yellow. Right. So yellow goes to the blue. Can you see that? Goes to the blue. Which is GPIO 13 on the Raspberry Pi. Right. And then the next colour is blue. Now you can do whatever colours you like. You can do whatever colours you like. I'm just following the guidelines. So blue, which is GPIO 6, I think. We'll have a look when we do the configuration. That goes to the green. And then you've guessed it, the green goes to the red. Right. The last one, the green goes to the red, which is GPIO 5, it looks like. My eyes are not as good as they used to be. And that goes to the red on the RGB LED. Right. Now let's put that where you can see it. Hang on. OCD. Okay, you can see that. Yep, you can see that just down in the bottom corner. We're going to be using the 3 of these, and we're going to configure that in just a minute. Right, let me come down to this view. Yep, you can see this view. Right, let's open Thony. There we go. And let's go to our normal. Let me just get the keyboard sorted out. Let's go to our normal. So we're opening. And we're going to open our template. All right. So we're opening our template. And call it what you want. What you like. Let me just go here. But I'm going to do a file, save as, and I'm going to call mine colourful light. Bumpy text. .py, the Python extension, and we'll OK that. Right, got that. So we're all set up, ready to rock and roll. Okay, yep, we're all ready to rock and roll. Okay, so let's start. Import IPI.GPIO at GPIO. Import time. From ADC device. Import. Remember, it's a star. Right, the wild card. Okay. Now, next attribute, we've got a number of pins. LED pin equals, it's 29. Right, because remembering that these are using the BCM numbering system on this board, but we're using the board, the physical pins. All right, so it's 29. So, sorry. Let's go back to here. We're going to name it red pin, okay? LED red pin. Go to the next one, LED. Green pin, and that's equal to 31. And then it's LED blue pin, and we're going to go to 33. Yep. Okay. So that's our pins, our attributes. Now we've got to do the ADC equals ADC device. Remember our number? 48. Remember in a previous video we looked at what our ADC device was on. So this defines the class object. We've done this before. But it wouldn't be so bad if I did the, hopefully you're shouting at me, ADC device, okay? Right, let's go to our setup. We need global. Yeah, but it's global ADC. Yeah, done that right. Global ADC. Now we've got to put in the if statement, right? If brackets on ADC dot detect I2C and again brackets off. Yeah, so what that's doing, that's detect the PCF 8591 PCF 8591 chip that's on the board. Yeah, the converter, and then that's colons. It gives us our auto indent. Yeah, gives us our auto indent. ADC equals, and it's the ADS converter as well. ADS, remember it's a 7830. That's the number of it. And again, 0.48. Right, that looks okay to me. Find out when we run it. So enter backspace, else, colons, auto indent, after the colons. Then we got that print command. Yeah, that takes ages to put in. So what we do, we go to here and right click copy. And yep, and Control V. What you can do, instead of doing, I like to do it that way, right click copy, you can do Control C. Once you've highlighted it, Control C. Cool. So that's our else statement. Then we come to our global. Right, let me just come down to where I am. I don't want to get lost. Our global P. Let's come here. So it's global P underscore red, capital R, comma, P underscore green, capital G, comma, P underscore blue, capital B. All right. So that's giving us our global attribute, if you like. It's giving us our global attribute. Yep. GPIO.set mode. Right. GPIO.board. The physical pins. Don't know what I did that. And now we've got our 3 setups. So we're going to do 3 setups, and they're GPIO dot setup. Yeah. And it's LED red pin. And it's a, comma, GPIO dot out, capitals. Yeah, capitals. Now what we can do, because we got all other 3, Control C to copy. Control V. Control V. Let's take these, tab these back out. Right. And take the red, and it's green with a capital G. Remember, because we did bumpy text. Take red out again, and we put blue. Okay, so this is set in the RGB pins to an output mode, so they're output. All right, because we're going to the RGB LED. Cool. Don't know why that keeps. Let me just check that I haven't done something wrong. But I don't know why it keeps giving me an automatic indent. I really don't. Right. Then P underscore red equals GPIO dot PWM capitals, brackets on, LED green pin, comma, 1000, brackets off. This configures the PWM for the LED and sets the frequency to 1 kilohertz. Okay, 1 kilohertz. Let's go to our next part. Why does that keep doing that? Let me just check I've got this right. Yeah, I can't understand why that keeps doing that. So, P underscore red, full stop, start, and we want it to start at 0. P underscore green equals, again, it's the hang on, right, I've got it. I've just noticed what I've done. Take out the green. You've got to do each one of these for each pin. I jumped the gun on the excuse me. Let me just check. Green. Right. What we can do, I like this. Control C. Control V. No. Something's going on. Oh dear. Not having a good day. Control C. Control V. Control V. Okay. Let me just separate these so you can see what we're doing. So we've got red. Green. So we're changing all of the attributes to the right colour. Yeah, that's what we're doing. Green. Then we'll come down and we'll do blue. Some of you might not think it's quicker, but I do. I think it's quicker than typing out, because my typing's rubbish. Really is rubbish. I'm a single finger typist. You know, I wish I would did do typing at school and learned how to type properly, but never did. Right, so let's just check that. Yep, we got red pin, green pin, blue pin, red pin, green pin, blue pin, and then we've got the 3 GPIO PWM frequencies for red, green, and blue. Right, okay, that looks good to me. Let's come down. Let's go to our while loop. While true, and true is always true. Value underscore red, capital R, equals ADC dot analog read, capital R on the read. Yeah, 4, brackets off, brackets on, 4, brackets off. Okay, read the ADC value of the 3 potentiometers. Okay, put the V in there. So that's what we're going to be doing. Right, it's going to read the potentiometers of the for red, green and blue. So now we put a value dot underscore green equals ADC dot analog read and that's going to be 3. All right, let's go down to new. Next one is value underscore blue with a capital B equals ADC dot analog read, again with a capital R, brackets on, and that's going to be a value of 2. All right, okay with that. So we've set the ADC value of the 3 potentiometers. I've been saying pediometers or something, you know. And oh, sorry, that's the wrong button. Enter. And now we're going to do our change duty cycle to read the value of the potentiometers into pulse width modulation, and that is P underscore, just see where I am, red, capital R, dot change duty cycle, capital C. Oh, won't be so bad if I put it there, would it? Capital C, capital D, capital C. And this is red, right? And so I just need to read this before, yeah, I can see that, yeah. Brackets 100 dash value underscore red star 100 255 brackets. Yeah, so we're mapping the value of the potentiometers, right? What's important about 255? It's the most highest number in an 8-bit binary. So what we do here, we've got to do one for green and blue. So easiest way, I think it's the easiest way anyway, if I can get it right. Really difficult when, because normally I'd be up here with my mouse and keyboard, Control C, but because it's down, it's difficult to use the mouse really. Right, so red, green. So wherever there's red in this line, we change it to green. That's cool to me. And on this line, blue. And all the numbers and everything else is the same. Right? So do this. Now I'm going to find this next command a little bit difficult, because let me just see if we got it on this one. I don't know where. I've got my forward slash, but I don't know on this machine where the backslash is. I really don't. And I've looked and looked, and I really don't know where it is. Hopefully you guys can find yours, but I don't know where mine is. So we're going to print the ADC value. Right? Print. Quotes. Quotes. ADC value. ADC value. Value underscore red colons %D. Remember we've had this command before? Gives you percentage of the display. Now it's backslash. Bear with me, I'm just going to see. I've got a backslash here. See what I can do. I just thought about this. Let's click on here. Oh, bear with me. Control copy. Control C. B. There we go. We've done it. Backslash. TVLUE underscore green colons %D. Right, comma. And backslash again. T value blue. So we've done the T. Oh, I'm glad I reviewed that. So we've done the red value, the green value, and now we're doing the TV. What's going on here? Bear with me. Let me come back. Getting all tangled. TV value. Right. T value underscore blue %D colons off, and then %. I think we've had this in we did have this in a previous project. So, and this brackets on value underscore red, value underscore green, value underscore blue, value underscore red, comma, value underscore green, comma, and value underscore blue. Brackets off. Right. And brackets off again, because we've got, hang on, let me just check. Yeah, because right at the beginning, just to show you, we got the bracket there, so we have to close it off. All right. So after the print, we'll put a time dot sleep. Brackets on 0.01. Brackets off. Right. I didn't spell that very good, did I? Right, file. Let's do a save. All right, let's do a save now. Come to our destroy. Remember, on the destroy we have to do the ADC dot close, brackets on, brackets off, and then want GPIO dot cleanup, and then our if and accept. Yeah, let's go through. Yeah, try. Yeah, okay. Now then, hopefully we won't have no mistakes. We won't have no mistakes. Let's run it. Syntax error line 3 from. Right, okay. Don't know why I put a space in there. Moved it to a different line. Right, let's run it again. Line 13. Line 13. ADC equals if ADC dot detect I2C global, go through, ADC equals ADS 7830. I can see the problems. Instead of a full stop, it's an X times. All right, good. Spotted that mistake. Let's just make sure it's nowhere else. Yep, it's up here. It's always good to have to do your debugging, yeah. Right, let's try again. Let's run it again. Line 13 again. If ADC, saying I shouldn't have a semicolon. ADC dot detect I2C 48. Oh. ADC. Anybody see it? ADC. Global ADC. If. Now, trace back most recent call. Bomb. Line 13. If. Why is it pointing the code? And then oh. Don't know. Let's Control C. Anybody see it? It's definitely dot, not comma. It's definitely an I2C. Text 0. Ah, I know what it is. Seen it. Didn't close off the second bracket. All right. Didn't close off the second bracket. Let's do a file. Let's do a quick save. Yeah. And let's try again. Line 55. Deary dear. Let me just come down. I think I know what it is. Yeah, that's tabbed in. Don't want that tab. Right. Right. Let's go. Fingers crossed. Oh dear. ADC device is not defined. You know why? Put a D in there, did I? ADC device. Well, we got lots of mistakes in this one. And we? Lots of mistakes. As I say, it's that's why we're here. To learn. Should we try one more time? Let's go. Here we go. Finally. Right. Let me just come over to this. You can see at the bottom all the values going through. What I'll do, I'll just change one of the values on the first. If you look here, the first potentiometer, that's high, low. The second potentiometer, high, low. Right. And the fourth, high, low. High, low, high, low. Okay. So let's go across to our LED. Can you see that? Here's the LED. So our first potentiometer, let me just turn this one off, is red. Yeah. Turn that off. Our next potentiometer, green. Okay. And finally, blue. All right, finally blue. Now what we can do, we can change our different colors. Hopefully you can see it okay. Let me just can change our different colors by moving our different knobs. Purple, can you see that? It's not very good in the camera, is it? Blue, and just move the colors up and down until you get the correct color. Well, we had a few issues with the code, but debugging is all part of the fun. Hope you enjoyed the video. I certainly learned something. But as you can see, as we move on, we're getting more and more complex projects. Hopefully you join me for the next video. Please don't forget to subscribe, like and comment, and I'll see you next time. Bye bye.